Beneath our feet, the ground feels solid, calm, unmoving, eternal. But that stillness is an illusion. Far below, the earth is alive. It breathes, it shifts, it changes, and sometimes, it reminds us of its power through an earthquake. To understand how an earthquake is born, we must look inside our planet. The Earth is not a single, solid sphere, it is a layered world. At its heart lies a molten core, surrounded by the mantle, and above it, a thin shell of rock called the crust. This crust is broken into enormous slabs, called tectonic plates. Like pieces of a cosmic puzzle, these plates cover the surface of the Earth, drifting slowly over the hot, flowing mantle beneath them. They move only a few centimeters each year, yet their movement shapes mountains, oceans, and continents. But when these plates collide, pull apart, or slide past each other, the stress builds. Rock is not flexible. It bends, it cracks, and then, it snaps. When that happens, all the stored energy is released in a sudden burst. The ground shakes, waves of energy ripple through the planet. That moment is what we feel as an earthquake. There are three main types of tectonic movement. At divergent boundaries, plates move apart, allowing molten rock to rise and form new crust, like the mid-Atlantic ridge. At convergent boundaries, plates crash together, forcing one beneath the other, creating mountains and deep ocean trenches. And at transform boundaries, plates grind side by side, locked for years, then slipping suddenly, releasing immense power. The famous San Andreas Fault in California is one such place, a fracture line between two restless plates. When an earthquake begins, it starts at a single point deep underground, the focus, or hypocenter. The spot directly above it, on the surface, is called the epicenter. From there, seismic waves spread outward in every direction. Some move through the interior of the Earth, these are the P waves and S waves, fast and invisible. Others travel along the surface, rolling and swaying the ground, toppling buildings, shaking mountains, and changing landscapes in seconds. An earthquake's strength is measured by the magnitude, which tells how much energy was released. A small quake may barely be felt, while a major one can shift entire cities and reshape coastlines. The 9.1 magnitude earthquake in 2004, near Sumatra, released energy equal to thousands of nuclear bombs. It lifted the seafloor, displaced billions of tons of water, and triggered one of the deadliest tsunamis in history. But earthquakes don't just destroy, they also create. The towering Himalayas were born from the collision of the Indian and Eurasian plates. The islands of Japan, the Andes Mountains of South America, even the vast rift valleys of Africa, all are products of the Earth's restless motion. Destruction and creation, forever intertwined. Today, scientists study earthquakes using sensitive instruments called seismographs, which record the vibrations of the ground. Networks of sensors around the world watch for tremors, helping to predict aftershocks and issue warnings for tsunamis. While we cannot yet prevent earthquakes, each discovery brings us closer to understanding their rhythm, the heartbeat of the planet. Every quake is a reminder that Earth is not static, it is alive, dynamic, and ever-changing. It has been moving since the beginning of time, long before life began, and it will continue long after we are gone. From the smallest tremor to the mightiest quake, the message is the same: our world is in motion. It builds, it breaks, it renews. So when the ground shakes beneath your feet, remember, you are standing on a living world, a planet that has been sculpting itself for billions of years. The Earth trembles not in anger, but in motion, the endless, powerful motion that makes this world what it is.